Hello, welcome to the Discrete Mathematics course in the Department of Computer Science at Tennessee State University. My name is Ali Segman. I'm a professor of computer science here at Tennessee State University. In this short welcoming video, I'm going to introduce what discrete mathematics is and explain the contents of the course. And hopefully we'll see that it's one of the most fun courses in the computer science curriculum. Let's get started. This is Comp 3010 Discrete Mathematics here at Tennessee State University, and this is introduction video explaining what discrete mathematics is. Well, I asked many people about what mathematics is, because discrete mathematics is a branch of mathematics, but let's first discuss what mathematics is. I asked this question to many of my students and colleagues, and their answers typically clusters on the idea that mathematics is science. And some people say mathematics is art. So I want to discuss what art is, what science is, and where does mathematics fall in art and sciences. So let's get start discussing what art is. Well, art is simply the works produced by human creative skill and imagination. So basically art, the main keyword in art is creativity and imagination, okay? For example, when you talk about a sculpture, a beautiful painting, or a beautiful piece of music composed by a musician, or creative dance, these are examples of what? Art. In order to be an artist, you have to have that creative skill and imagination in you. Can you imagine being a musician and composing a beautiful piece of music without that creativity in you? And let's talk about science. Well, computer science, you're going to be computer scientist, and computer science is science. So it is important for you to understand what science is. As science is a systematically organized body of knowledge on a particular subject. In other words, every science discipline studies a particular subject. For example, biology studies what? Life. Astronomy studies space. Physics studies nature. Chemistry studies matters. Computer science studies what? Computation. Okay? Computer science does not study computers, it studies computation. Of course, you have to know a lot about computers and understand. Similarly, a biologist must be able to use microscope, an astronomer must be able to use telescopes, computer scientists must be able to use computers very, very efficiently. And it has a lot to do with computer science, but computer science main focus is what? Computation. Here, the key is observation and experimentation. And science depends on a lot on observations. So considering the fact that art depends on art, the main keywords in art are creativity and imagination, and the main keywords in science are observation and experimentation. What is mathematics? Where does it fit? Is it art? Is it science? Or is it both? Or is it none? In order to motivate you a little bit more, I want to talk about a famous mathematician, Galois. Galois, I took a course, actually I took two courses, 2 semesters of courses in abstract algebra while I was a PhD student in mathematics. Towards the end of the second semester, we were introduced with the theorems of Galois, and that was basically the start of abstract algebra. So Galois developed theories that simply laid the foundation of two major areas of abstract algebra. And Galois was killed when he was only 20 years old in a duel over a girl. And in his short life of 20 years, he developed major theories of abstract algebra. Well, can we say that Galois is not an artist? I mean, definitely the work that he developed is a piece of art to me. So mainly, I mean, to many people, mathematics is mainly art with a lot of intersections with what? Science as well. So we shouldn't say it's a science, we shouldn't say it's art, but it is mainly art with a lot of intersections with what? Science. So what are the areas of mathematics? We can consider mathematics as pure mathematics and applied mathematics. Under pure mathematics, there are a lot of areas like set theory and logic, number theory, algebra, combinatorics, geometry, topology, and mathematical analysis. And in applied mathematics, we can say calculus, probability and statistics, numerical analysis, differential equations, optimization, approximation theory, and many more. So just to give you some ideas of different branches of mathematics or areas of mathematics. So what is discrete mathematics? Well, where does it fit in the areas of mathematics? Discrete mathematics is a branch of mathematics that studies mathematical structures, but those structures must be countable or distinct and separated or separable. So discrete mathematics do not focus on continuous mathematics. It focuses on distinct objects. For example, real numbers are part of continuous mathematics and they vary very smoothly, right? But integers, for example, are objects that do not vary smoothly. So discrete mathematics mainly focuses on what? Distinct and separable objects. And integers are typically used to characterize those objects, and real numbers are typically used to characterize continuous objects. So discrete math does not deal with continuous mathematics such as calculus. Okay. So why do we study discrete mathematics? First of all, it's beautiful, okay? And it's the mathematical language of computer science. When you take upper level courses, you're gonna see that discrete math is part of them. In order to understand data structures, algorithms, for example, you have to have a good understanding or solid understanding of discrete mathematics. If you want to understand databases theory, if you want to understand formal languages, computer security, cryptography, for example, operating systems, discrete math is everywhere to represent structures in computer science. And it's highly important that you fully understand the topics that we discuss in this class. Aside from that, discrete math is going to help you think mathematically and analytically. So what are the contents? Well, one of the main goals of this course is to help you think mathematically and logically. You will understand and construct mathematical arguments using mathematical reasoning. In order to do that, we will start with discussion of foundational subjects of logic and how to use logic in various methods of proofs. Even though we will learn different methods of proofs, we will specifically focus on the technique of mathematical induction. And then we'll talk about sets, functions, sequences, summations, and matrices. Well, discrete mathematics deals with discrete structures that represent discrete objects. Sets are collections of objects. Many discrete structures are built from sets. For example, relations are sets of ordered pairs that represent relationships between objects. Graphs are the set of vertices and edges. Functions, for example, assign an element of a first set to exactly an element of a second set. Functions are very important in discrete mathematics. For example, we use functions to represent computational complexity of algorithms. We discuss sequences, which represents ordered list of elements. Sequences are typical, a special type of functions. In many cases, we had consecutive terms of a sequence of numbers. We introduced notation used to express summations. We introduced the notion of the size or cardinality of a set. We will call a set countable when it is finite or has the same size as positive integers. We will show that rational numbers are countable while real numbers are not. We use matrices to represent variety of discrete structures. For example, we represent similarity of the edges of a graph by a similarity matrix. Therefore, we will cover basic matrix algebra needed to represent relations and graphs. We will specifically focus on relations. We will show how to define relations between elements of sets. Relations map an element of a set to an element of another set. Functions are special relations. We will focus on binary relations and properties of relations such as reflexive, symmetric, or anti-symmetric, transitive. We'll talk about equivalence relations, partial and total ordering. And we will discuss algorithms in detail. An algorithm simply specifies a sequence of steps to solve a problem. We will discuss many algorithms such as searching for an element in a list or sorting a list. We will discuss how to define computational complexity of an algorithm. Well, number theory is an area of mathematics that studies the set of integers and their properties. We will particularly focus on some important concepts from number theory relevant to computer science. We will first talk about divisibility of integers and introduce modular arithmetics. As an application, we will introduce how number theory can be used in cryptography, for example. Well, counting. Counting is one of the areas that we're going to focus this semester. What is combinatorics? Combinatorics is an area of mathematics that studies the arrangement of objects. It is an important part of discrete mathematics. Enumeration is the counting of objects with certain properties. Counting is important in many areas of computer science. For example, in DNA sequencing or computing complexity of algorithms, we do use counting. We will introduce ordered and unordered arrangements of objects of a set with or without repetition. In other words, we will introduce permutations and combinations. Well, studying gambling was original motivation of probability theory. However, it is now essential in many disciplines. Probability theory is extensively used in determining complexity of algorithms in computer science. Probabilistic algorithms are heavily used to solve many problems that cannot be easily solved with deterministic algorithms. A deterministic algorithm always follows the same steps given the same input and generates the same output. However, a probabilistic algorithm makes one or more random choices, which may lead to different output given the same input. Graphs are discrete structures that consist of vertices and edges. Graph models are widely used to solve many problems in many disciplines, including computer science. We will show graphs can be used to model various areas. For example, we will show how graphs can represent who influence whom in a social network. When you have in Facebook or Instagram, when you have the list of friends, well, who's influencing whom? That is actually a problem that can be solved with graphs. And then a tree is a special graph. Trees are important in computer science. They are used in many contexts. For example, they are used in developing efficient algorithms, locating an efficient algorithm in locating what an item in a list, for example. They are used to study games such as checkers and chess. So, well, as I said, this is a very much fun area of computer science, and I hope you enjoy studying discrete mathematics. I must emphasize that it's extremely important that you understand and develop a solid foundation in discrete mathematics in order to be successful in the upcoming courses in computer science curriculum. I hope you have fun.